Alright, today we are going over inequalities. Multi-step inequalities today. You've gone over inequalities in the past. If you remember, they deal with, instead of an equal sign, they deal with these guys, which are, this is the less than sign, which you can remember because it makes an L, so less than. And Abby showed me this one. You can make this one into a G by doing this, and that's greater than. So we've got our less than sign, our greater than sign, and we also have our less than or equal to, or our greater than or equal to sign. Those are too close together. I'm going to move that. So we've got our greater than and equal to sign as well. So, and those denote expressions that have that value that it's set to, as well as the values before or after it. We're going to go through some examples so it makes some more sense. So for a less than equation, 4 is less than 6. Alright, that is always true. For a greater than equation, we can look at 6 is greater than 4, which you can recognize is just inverse of the first equation, which you gotta keep in mind. You can rewrite your inequalities, but you gotta make sure you keep track of where the sign is facing. For example, if you were trying to figure out what negative 2x equals 6, not equals, inequalities, less than 6 is, we need to get the x by itself. We divide by negative 2. That's the inverse operation of multiplication. Divide by negative 2, we'd get x, and negative 3. But with inequalities, if you change your sides with negatives by either multiplication or division, you swap the sign. So you've got x is equal to negative 3. A good way to remember this is look at it with just two numbers. If you had negative 4 and negative 6, you would say negative 4 is larger. But if you wanted to make it positive, you could by dividing by negative 1. Divide by negative 1 on both sides. That's how you get rid of the negative. That's going to give us 4 and 6. But 6 is bigger than 4. So we can't put less than. Instead, we swap the sign and get our new inequality. And then we're going to move on to greater than or equal to. We're going to talk about how we'd graph these actually. So graphing, say we're graphing x is less than 4. Here's our number line. I don't need that many. So we got our 0, our 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. X is less than 4. We're going to start at 4, and the answer for x is everything less than 4. That includes 3, 3.1, 3.9, 3.999999, just like infinite nines, anything before 4, but we just don't want 4. So when we graph a regular equation that does not have an equal involved, we want everything but that 4. So what we'll do is we will put a little bubble where 4 can be by himself. We do not want him, he is excluded. But we want every answer that is less than 4. So let's see, I'm changing colors. We want everything this way. And a good way to remember which direction you need to go in is look at the variable. Whatever direction the arrow is facing on that, when the variable is on the left side, is the direction you're going to go. So like, let me switch back to black. If we have x is greater than 4, or the number line, we're going to start 0 here. 1, 2, 3, 4, 6, 7, 8. We are going to start at 4 and go this way, because our arrow, our greater than sign, is that way. Just like up here, it's pointing this way, but that only works if our variable is on the left. And then we are going to look at greater than equal to, how to graph that now. So if we have x is less than or equal to 4, this is what we'll have. Excuse my terrible line. I am not trained to draw lines. 1, 2, 3, 4. 1, 2, 3, 4. Negative, 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 negative. Terrible negative sign. Equally as terrible. There we go. We are going to want to include, so for this one we want to include every value less than 4 as well as 4. So instead of excluding 4, we are going to include him. So we're gonna fill him in on what's happening. You're like, hey bro, did you hear that 7, 8, 9? Now 4 is filled in. That was a math joke, excuse it. But we're still going to encompass everything less than it on the number line. So inversely, if we look at x is greater than or equal to 4, we're going to have 0, 1, 2, 3, 4, 5, 6, 7. We'll make it even 8. X is greater than or equal to 4. We're going to start at 4 again. Let me switch back to blue. We're going to start at 4 again, fill them in on everything that's happening, and then include everybody else. So that's how we graph the negative, or the greater than or equal to, less than or equal to, as well as the greater and less than. So just to recap, less than is an open, greater than is also open, less than or equal to, we fill in, greater than or equal to, we fill in. Alright. And when we multiply or divide, by a negative number, I misspelled negative. Negative number, swap direction of arrow. I cannot spell. So left goes right and right goes left. We're going to work out an example on the homework. Look at number 1. So number 1 is set up in the format 3 is less than negative 5n plus 2n. So we would work this out just like we have been doing with our regular equations. Inequalities are not any different in terms of solving. It's just the solution is going to differ. So when we combine our like terms, we've got a negative 3n is less than 3. And we're going to get, we need this n by itself, so we're going to divide by negative 3, not 33, Mr. Bowles. cancel out. Negative 3. That's going to get us negative 1 and n. But remember, we divided both sides by a negative, so we're going to swap the sign. N is less than negative 1, or negative 1 is greater than n. So we got to listen to what the equation is telling us. The variable is on the right. Can you guess which way the arrow is going to face on the number line before we graph it? Hint, another way to look at it is n is less than negative 1. Plot in our number line. Okay. So we're going to start at negative 1, and since it's just a regular sign, we're excluding him. But what direction do we go? We look at it, we listen to what the equation is telling us. Negative 1 is greater than n. N is less than negative 1. So we know negative 1 is going to be the greatest value, and we want every value that n is going to be. So n can be anything less than negative 1. That includes negative 1.00000000001, as well as 2, 4, or negative 2, negative 4, negative 1,000, all of that. So we want to include all those guys. So we are going to include them all. Alright, but on the homework, I want you to do it in the format, I want you to graph your lines like this. I'll show you. I want you to graph it like this, above the line. That way I can easily see it, because on this it's going to be hard for the pencil to show up, especially when you scan it and send it. It'll be a lot easier to grade this way, and it'll be a lot easier for me to tell what you're doing. Let's look at number 1 in a different light. So let's say negative 1 was set up as, or not negative 1, problem 1 was set up as the form, I'm just going to go to a new page, was set up in the form of negative 3n is less than negative 5n plus 2n. So same thing we did last time, combine like terms. We've got negative 3n less than negative 3n. Now, we gotta be careful when we're combining terms. We're gonna divide both sides by negative 3n, by negative 3n, or you can do it just, you can just divide by the negative 3 and leave the n's. It's going to get n is less than n. Or if you do it this way, you're going to get 1 is less than 1. Both are correct, because honestly they still simplify the same thing, like n less than 1. You can do minus n, you got 0 less than 0. Same thing here, minus 1, you got 0 less than 0. Now in the previous homework, if you'd reached a point like that and it was like 0 is equal to 0, we would have said all solutions, all real numbers, like you can use anything. But on a less than problem, we have an issue, because if you think about it as 1 is less than 1 or 0 is less than 0, that's not true. They're the same number. One doesn't have a greater value than the other. So this would be a no solution. That's one thing you have to look out for when you're doing these problems, is just look at it and read it out loud and ask, does this make sense? So when you come across a problem like this, it's going to be no solution, unless it was set up as 0 is less than or equal to 0. Then that would be okay. That would be a solution. That wouldn't be a no solution. So that is our inequalities refresher and expansion. The homework is going to be that multi-step inequalities worksheet that I'm going to email you with directions. Just problems 1 through 14. I look forward to see how you do, Rylan. Hope you're doing well.